Okay, so yesterday we did problem 1 and problem 5, I think, right? So you guys can work on problem 2 and problem 3. And I'll give you guys like about 4 to 5 minutes to practice those 2 problems. And then we're gonna go over. So again, we're working on problem 2 and problem 3. Yes, I should have done it before. The formula for, I'll write it here then. Again, this is the place where it should have a different sign, so A, B, and this is the place where it always should have a positive or plus sign. There you go, that's your formula. And again, we are working on number 2 and number 3. So again, just for a quick recap, you have to figure out if it's if the given expression, if it has 2 perfect cubes or not, right? If it has 2 perfect cubes, well, check, then you just figure out what your A and then what your B is. Again, your A and B, those should have been the cubic roots of your given numbers and expressions. So once you figure that out, you just plug them in the formula. So just look at the given expression, ask yourself, can you factor out the GCF? Is there a GCF factorable? If that is, then factor out the GCF, then it should have been more visible to you that if that expression is difference or sum of perfect cube or not. That is correct, Maggie, for the second one. For number 2, you got it right for the second one. Good job. Zarif, are you done with the second one? If not, we can I'll go over the second one.
All right.
Okay, you want me to go over it?
Yeah.
Okay, sure. Not a problem. Not a problem. Okay, so for the second one. Okay. So we are given this expression in here and we are asked to factor it, okay? So then what are we supposed to do? Well, we're supposed to ask ourselves, are the 2 terms given in here perfect cubes? So what I'm essentially asking you is that for the first term, it's just a plain variable raised to the 3rd power. So that should tell you, well, yeah, that is a perfect cube because the exponent, it has an exponent of 3. So check for the first term, right? Check. How about the second one? You are given a number, which is 27. So you're supposed to ask yourself, is 27 a perfect cube? So you are also asking yourself, is there a number that if I multiply 3 times, will it give me 27? So there has to be a number. If you multiply the same number 3 times, that will give you 27. Is there any such number, Zarif?
Wait, can you
What number? Yeah, sure. What number, if you multiply 3 times, will give you 27? Are there even any such numbers? Like if you multiply that number 3 times, that will give you 27? Remember, there was a chart yesterday that we had, and the chart had all these cubic roots and perfect cubes. Hold on. Can you like remember off the top of your head, like?
Is it 3?
Yup, that is 3. Hold on. That is actually 3. So 3 times 3 times 3 gives you 27. So 3 is actually that magic number that if you multiply 3 times will give you 27. Well, then you are supposed to write it in your cubic root form. So if you want to write this expression like that, you have to write, the first one was already done for you. They already told you the cubic root. So x to the 3rd power plus 3 to the 3rd power, because you know that if you multiply 3 times, it will give you 27. So what you did with this 27 is you cube rooted 27 and you got 3. And you're supposed to write that 3 here, right? And now you just plug it back into the formula. You know x is your A and you know 3 is your B, right? So, and then you are adding 2 perfect cubes. So you should plug this back into this first formula that you have in there. So your x is your A. So x plus 3, because it's A plus B, And then a squared is just x squared because x is your a. And then you're supposed to have a different sign in here than what you had originally. And you're supposed to multiply 3 and then x because those are your a and b, plus b squared, and then your b is 3. And then if you square 3, you get 9. So this is your final answer. Did it make sense, Sarif?
Yeah.
It still sounds kind of like not very smooth and not very easy, right? Still, it's kind of difficult. Well, the main thing with this whole adding and subtracting perfect cube is that you have to figure out the perfect cubes first. Once you do that, it's easy. You just plug it back into the formula and it's right there. But you have to figure out the perfect cubes first. It's gonna, I think it's gonna get a little better once you do like a couple of more practice problems. Let's take a look at the second one then, okay?
Does that become minus all the time?
Ooh.
It was -3 thing. Yeah.
Oh, in this part, like
It's
here?
square -3x. Yeah.
Here? Yeah, that is like, okay, it says in the formula, look, when we did the formula yesterday, I told you guys this is the only place where you are going to have a different sign than what you had in here. So if you had a plus in here, it becomes a minus. And if you had a minus in here, it becomes a plus.
Okay.
So this is the place where you, actually the place where you change the sign. So that is actually given in the formula. So, you know, you can't really do anything other than like other than doing whatever the formula is like telling you to do. This is the only place that this like the in here and then in here, in these places you are gonna have like a different sign than what you had in here and here. Okay.
Wait, the answer was the x plus x cube plus 3, and the other one is over here.
You're talking about here. Oh,
The answer.
like that place had an X. Is that what you're trying to say?
Yeah.
Yeah, it did, but then I was like erasing it because I thought we were gonna move on. Yeah, it did have an X in here. So that was like what the original answer had, but then I was like erasing it.
Okay.
Does it make sense now?
Yeah.
Any other questions?
With the square, the x won't have any cube on top.
No, the X doesn't.
Okay.
Look here, Zerf. Let me actually tell you this. Look at the formula. Okay, the formula only has A and then B. No numbers, no coefficients, anything. The formula just has plain A, B, and then those are like raised to the third power. So what you are supposed to do is that whatever given expression you were given, if you want to apply the formula for like sum or difference of perfect cubes, you have to make that expression look like this. It has to look like that. What I mean by that, look like that in terms of the exponent. Look at this thingy right here, and then look at this. You have a to the cube power, so a to the third power, and you have x to the third power. So this, like, you know, these two, they look like each other, right? And then for the second one, you had to make it look like b to the third power, right? So you had to, whatever your base is, right? Whatever base you have, they can be different from each other. They can be different from your formula, right? But then they have to have that exponent of 3, right? They have to look alike in terms of the fact they should both have an exponent of 3, right? Okay. All right, hold on. Okay, so I told you guys to practice number 3. Maggie already gave me an answer. Let's see what actually happened in there. Okay, so for number 3, I do see something that the previous problem didn't have. So what is that thing? Well, this is the thing. The previous problem just had like x to the third power, but in this problem has a to the third power, right? So like I was saying yesterday, if you have like a coefficient with the variable, you have to make sure that that coefficient is actually a perfect cube, right? 8 is a perfect cube because if you cube root 8, you get 2. So what I just told you is that if you multiply 2 3 times, you get 8, right? So when you are doing cube root, when you are cube rooting 8, you get 2. So you have to rewrite this expression in this. So whenever you are given an expression and then you are asked to apply the formula of sum or difference of perfect cubes, you are supposed to make that expression look like either this one or that one, right? So I think I will have to make this given expression. I think I'll have to make this given expression look like this one right here. Okay, then let's work. I just told you that cube root of 8 gives you 2, right? So I'm gonna write 2 and I'm gonna write a, and now I'm gonna erase this whole thing to the third power. Why did I do that? Well, I did that because I just told you 8 is equal to 2 to the third power. So instead of 8, I'm replacing 8 with 2 to the third power, and I have 8 to the third power with it. So if I'm gonna write this in a more like acceptable way, what I'm gonna do is I'm gonna do this. This is the same thing as that, and that is the same thing as this. But this is like a more I don't know, this is a more acceptable form in mathematics. So they ask you to write it like this if you have anything like that. So I just wrote this thing right here as that. So once I did that, I'm okay for the first term. Now let's work on the second term. I have 27. Well, why am I using the formula on the bottom instead of the top? Oh, I'm sorry, Maggie. That was my bad. It should have been the formula at the top. Thank you for paying attention and mentioning that. Yep, it should have been the formula at the top because it is sum of perfect cubes, not difference. I kind of like missed that part. Yeah, so it was sum of perfect cubes. So I'm supposed to use the formula at the top, right? But so far we are okay. I just said that thing wrong. My bad. And thank you, Maggie. So once I do that, I know that like 27 is a perfect cube, right? Because if I do cube root of 27, I get 3. So what I essentially told you in here is that if you multiply 3 times, you're supposed to get 27. Okay? So 27 is a perfect cube. And if I cube root 27, I'm supposed to get 3. So I'm gonna write that down here. 3 to the third power. Now this looks like this expression that is what we expected, right? So now we're just gonna plug and chug into the formula. Well, this is my A. This is my A right here, and this is my B right here, okay? So we have to do A plus B, and then A squared, right? So I'm gonna use like a bracket, and in parentheses, I'm gonna put 2A squared minus, remember, this is the place where you're supposed to have a different sign, minus A times B. So that should have been 3 times 2A plus B squared. Now I'm supposed to simplify this one. Remember, for factoring, you're supposed to simplify, okay? Keep your answer in the simplified form. So 2A squared, like if it's a whole square, what I'm supposed to do is like 4A squared. How do I get that? So 2A whole squared, right? So this is essentially 2 squared times A squared. Welcome back, Zarif. Okay, so that
my
is...
bad.
It's okay. It's okay.
I was not
2A whole
sleeping.
square. It's okay. It's okay. As long as you're paying attention, I'm good to go. It's 2A whole squared. So that's like 2 squared times A squared. So I'm gonna rewrite that as 2 squared is like 4, and a squared is just a squared. So that is how I got 4a squared from this. Okay, that is what I wrote in here. And now I have to simplify this part. Well, 3 times 2a is just 6a minus, and plus 3 squared is just 9. That is your final answer. Yeah, do we have any questions? Any questions, clarifications, comments? Did it make sense? Yes? Can we do another problem? Sure, we can do as many problems as you guys want. Okay. Try number 3. The one that's down here. Try that one. And I'm gonna give you guys about 2 minutes to practice that problem. Just to give you guys a heads up, look at the given expression, observe it, okay? Just try to ask yourself, what am I given here and what am I supposed to do, okay? So you see like it's 125x to the 3rd power. Remember what I told you, that entire term has to be raised to the 3rd power, right? But that doesn't mean that you can raise 125 to the 3rd power, because if you do that, you are now like, you know, introduced a whole different number that is way different than 125. You cannot change whatever you were given. You can modify it, but then it has to end up having the same value as you were given at the beginning. So modify that, but do not change it. So 125, ask yourself, is that a cube? Is that a perfect cube? If so, what is the cube root of 125? Once you figure that out, ask yourself, is 64 a perfect cube? If so, what is the cubic root of 64? For the first one, I know it's a big number, 125, but because it has a 5, it might be divisible by 5. Because if a number that ends in, if there's a number that ends in 5 or 0, it should be divisible by 5. I'll give you guys 1 more minute. Well, Maggie, for your answer, you're like so close. But remember, whatever your A is, you're supposed to put that whole thing, you're supposed to raise that whole thing to the 2nd power. So what I'm like telling you is that, look at this part, right? Look at this part. Okay, I mean this part. This a squared right here. Hold on. Look at this part, this a squared right here. That whole a, whatever your a is, you're supposed to raise that whole a to the 2nd power. So whatever you called your a, you're supposed to raise that whole thing to the 2nd power. Do not just raise the number or the exponent. You have to raise that whole thing. So from your answer, I can tell that you chose 5x to be your a. So if that is your a, you're supposed to raise 5x, that whole 5x term. Yep. So then, yeah, that 5 should be raised to the 2nd power, and that x should be raised to the 2nd power. If you did that, then that should be good. Okay. All right. Let me go over. Okay. Zarif, are you done or close to being done? Or are you stuck? Stuck? Okay. No worries. I'm here to help. Scroll a little bit down. Okay. already. Okay. So our problem is this, right? So like I was telling you guys, you have to ask yourself, okay, so 125, I know x, right? They already told me, they already raised x to the third power. So, that's just telling me, okay, that is, we have a perfect cube right there. How about 125? Is it a perfect cube? Well, just by thinking about it, I can kind of tell you, yes, that is, because if I multiply 5 3 times, I get 125, okay? Like I was telling you guys, you should know like the common like perfect cubes. So like what happens if you multiply 3 3 times, 4 3 times, 5 3 times, kind of like that, right? So I know that 125 is a perfect cube because if I cube root 125, I get 5. Okay, so that is what I'm gonna write in here, because if I want to perform sum or difference of perfect cubes, my expression should look like this one, the one that I have, the first one. So I have to make it look like that, right? Okay. So I know that 5 is like the base, and if I raise it to the third power, I should get 125, okay? And now I have x to the third power. And I just told you guys in the previous problem that if you have something like this, you can write it like this. Yeah? So let's do that. I know 64 is a perfect cube because if I multiply 4 3 times, I'm going to get 64. So what I just verbally told you is this. In other words, if I multiply 4 3 times, I'm supposed to get 64. Okay, so I'm going to write 4 and to the third power. Now this expression looks like whatever I wanted to see, this one right here, right? So now 5x, remember guys, I was just telling Maggie that your entire 5x is your A now, and this 4 is your B now. You have to keep that in mind, because if you cannot identify your A and B correctly, you are not going to end up having the right answer, okay? All right, so the formula states A plus B, so 5x, since it's my A, 5x plus 4. And for the second part, I'm supposed to do A squared. So whatever my A was, I was supposed to square that, okay? So, and I just told you that my A is 5x. So I cannot just square x and call it a day, and I can't just square 5. I have to square both of them, because 5x was my A, right? So if I tell you A squared, right, that should be equal to 5x squared, because I told you A is my 5x. Yep. A is 5x. So if A is 5x, A squared should be 5x squared, the whole thing squared, right? So if my A was like, let's say x, y, z, then my A squared should be x, y, z whole squared. I have to raise all of them to the second power. You cannot just raise one to the second power and leave the other one out. You can't do that, right? So A squared is 5x whole squared. Well, that should give you 25x squared. Because if you do it individually, I'm just telling you this is equal to 5 squared times x squared. So 5 squared is 25, and x squared is just x squared. And this comes down to the x squared. So this whole thing is equal to this, 25x squared, okay? So that is what I'm going to write in here, because the formula told me to do the formula told me to do a squared. So 25x squared. Remember, it cannot be a plus, it has to be a minus. And I'm supposed to do a times b. Okay, so 5x times 4. And I'm supposed to do plus b squared, and my b was 4. Okay, we reached to that part. Now we're supposed to simplify, okay? And if you want to simplify, Okay, so if you want to simplify, it should have been 5x plus 4 and 25x squared minus 5x times 4 is 20x plus 4 squared is 16, and that is your final answer. Maggie was so correct, but she probably messed up identifying the A and the B correctly. Remember, guys, that entire first term that you have in here, that entire term is your A. So it doesn't matter if you have two variables, doesn't matter if you have two numbers, whatever you have, that is your A. You have to consider the entire term, okay? Did we understand this? Okay, you are still confused as to why that is that. Okay, hold on, Maggie. Okay, Maggie, look. I just told you that I just told you that your A was 5x, right? So now if your A is 5x, what should your A squared be? If I'm squaring A, I should be squaring whatever it is equivalent to that I just said. So if I'm squaring A, I should be squaring this entire term. I can't just square x, or I can't just square 5. I have to square everything that I just set equal to A. Okay? So I have to square this entire thing, right? And to simplify this, this is essentially 5 squared times x squared. Well, 5 squared is 25, and x squared is just x squared. That's why 5x, if I raise this entire thing to the second power, or if I square this, it should be equal to this. Did it make sense, Maggie, now? Yeah? No problem. Okay, so do we still want to do more practice problems with this cube, sum or difference of perfect cubes? Or you guys want to move on to something new that I had planned for today?
Something new?
Something new. How about you, Maggie? I mean, I can sit here and do these problems with you. Guys, I have no problem, absolutely no problem. Okay, sure. We know we are like sick and tired. Okay. But if you guys are still confused with sum and difference of perfect cubes, what I would recommend is to do the practice problems. We did most of them together throughout yesterday and today, but you guys can still practice them. The problems are up in Google Classroom and come with questions the next day we do have our lesson together, okay? All right, so our new topic is actually rational expressions. So we are going to learn about multiplying and dividing, but for today, we are just going to learn about multiplying and dividing. Oh, and then we are also going to learn about adding and subtracting, but that is for our next lesson, for our next day. So just for today, we are going to learn about multiplying and dividing rational expression. So our aim is, how do we multiply and divide rational expression? So for that, I want to tell you guys what a rational expression is. Well, what does it sound like? It literally sounds like ratio, right? It says rational ratio right in there, right? It literally has the word ratio in it. Look right here, ratio, right? So yeah, like I was telling, it is actually a ratio. So it is actually a fraction that has a denominator and a numerator. So it has a top and the bottom, right? But look, it can be of like different forms. Like it can have like, 10,000 different forms. For the first one, you guys can see that the top does not essentially have any variables or anything. It's just a constant. You can have a fraction like this, and that is still a rational expression. For the second one, the top now has a variable, and that is a binomial, right? And the bottom is a trinomial, so you can have like denominator and numerator of different degrees, and that is a rational expression. And for the last one, it looks super complex, right? Because you have like, I don't know, the top is like factored for you, the bottom is not, right? And that is also a rational expression because there's something at the top and something at the bottom. As long as you have a denominator and a numerator, that is a fraction, and that is a rational expression. For it to be an expression, it actually has to have variables in it, okay? Which is what we call it a rational expression. Well, then how do we multiply rational expressions? So instead of me like throwing the steps to you guys, right? What I want to do is like I want to introduce you guys, not like necessarily introduce, but like talk you guys through using numbers, right? So we all did this in elementary school, right? We multiplied like fractions together using different numbers. So that's what I want to do with you guys, because if you know how to like multiply fractions that have numbers, you know how to like multiply rational expressions, right? So for the first term that we have in for the first one that we have in here, it's 3/4, and the second one is 10/9. And now we're asked to simplify this, right? So what they're telling me with this dot in here is that they're being multiplied together. Yeah, they're being multiplied together. Okay, so then let's multiply. So in the second step, what I did was like I broke them down. So 3, I cannot break it down any further, but for 4, I can break it down. I wrote all the multiples of 4. So all the multiples of 4, well, the basic one, the one with the basic ones basically is that 2 and then 2. 1 and 4 is also multiple, right? But the 4 can also be like further broken down into 2 and 2. So then I wrote that. And then for 9, I wrote 3 times 3. I broke it down, right, into its factors, right? Here's the thing. Now you guys are telling me, Tamana, we all know that we can just like, tell you the answer from here. We don't have to do this step, this, and then go there. I can just tell you what this should be equal to from here. Well, I'm just doing it because you're going to see how it applies similarly when we do it with expressions, okay? So just bear with me. Okay, so in here we factored this given expression, right? And then in this step, what we did was like we canceled out the common factors, right? So when we factored, the main purpose of factoring was to figure out the common factors. So once you see the common factors, you can cancel them out. Well, I saw 3 in here, 3 in here. I color coded them so you see them, right? So and then you cancel them out. I see a 2 in here, 2 in here. I canceled them out. Well, if they get canceled, I'm only left with a 2 at the bottom and a 5/3. So then I multiply across, and 3 times 2 gives you 6, and 5 times nothing left. So here you have just the 1, right? And then 5 times 1 gives you 5, and then 3 times 2 gives you 6. That's your simplified answer, right? Okay, enough with the numbers, okay? We are big boys and girls. Let's see what happens when variables come into play. Whew. So we have this in here now, right? So now we are being asked how to multiply rational expressions, and now those expressions, right? The first one and the second one, they have variables in them. Do not get scared because it's the same thing, right? It's the same thing that you just did before. What was the first thing that we did? Well, the first thing that we did was to factor them. We found what the factors were for each of the numerators and denominators, okay? All right, then let's do that. 3x², that can be broken down into 3 times x, right? Because we all know x² is just x times x, right? And then 2 does not, there are no factors. Well, you have 1, but you don't have to write it down like that. And then the same thing for this 2. And then 9x can be broken down into 3 times 3 because 9 has 3, like 3 times 3 equals to 9. So then you factor that. And now you look for common factors. Well, the common factors in here, you have a 2 here, you have a 2 here. You have a 3 here, you have a 3 here. You have an x here, and then you have another x here, right? Okay, you guys can disregard this part because we are going to do this later. So now you just cancel out the common factors. Well, you can see here, they're being canceled out, right? Cross them out. This is a more complex example. Let me just run it down. Let me just run it through you guys really quick, okay? So even if I told you it was a complex problem, it literally follows the same step. We have a numerator right there and the denominator right there, okay? Same thing, same thing. So now for the previous examples, we factored them. We factored the top, we factored the bottom. And this does not go any different. Do we factor the top, factor the bottom? So factor this one. We literally learned about factoring the other day, right? So what is this expression? That's a trinomial. So what I'm being asked to do in here is to perform trinomial factoring. And how do we factor trinomials? Do we remember how to factor trinomials? Okay. In order for you to factor trinomials, what I told you guys is SP method. What is SP? I'm sorry. So what I told you guys is that in order for you to factor a trinomial, you have to put the variable. Oh, your teacher called it that, but I don't know about that either. But then this is how you do it. I don't know if there's like a definite name that you can call it, but this is how you do it. You're supposed to have like two parentheses, right? And then you put the variable first. And now you're actually supposed to figure out two numbers that if you add will give you the middle number, and if you multiply will give you this last number. So what I'm telling you is that what two numbers, right? If you add gives you, well, negative x is just -1, right? I can call it -1. What two numbers, if you add them, will give you -1? And what two same numbers, if you multiply the same two numbers, will give you -6? It's kind of like a trial and error way. Like you have to like try different numbers until you get the middle number. Like if you add them, you get the middle number, and if you multiply them, you get the third number, or the third number. -3 and -2. So if I add -3 and -2, do I get -1? I'm just gonna write out what you just told me, because that should make more sense. So if I add -3 plus -2, does that give me -1? Because what you just told me is this. Does this give you -1?
No, that's give you -4.
-5.
Yeah, my bad.
It's okay. Yeah, that gives you -5. So, well, that does not work, but good try. I mean, we kind of know that the numbers have to be 3 and 2, because the factors of 6 are like 3 and 2, right? So you have to do something to that 3 and 2 to make it like, if you add them, it will be equal to -1. If you multiply, it will be equal to -6. What should you do? Well, okay, here's another thing. Let me give you another clue. There will be a minus here. Yes? -3 plus 2 gives you what? -1, right? And -3 times 2 gives you what? -6, right? Do we agree? Yep. So I knew this was going to be minus, because when you have a trinomial expression and you were asked to factor them, whatever sign you have in here, that should be the sign of your first bubble, like your first parenthesis should have the negative sign. Wait, Maggie, you said no to what? -3 plus 2 does not equal to -1. Oh, here, Maggie, look. Oh, -3. Oh, okay, yeah. Yeah, so For this one, the two magic numbers, that's -3 and then 2. Because if you add -3 and 2, you get -1. And if you multiply -3 and 2, you get -6. Are we clear with that so far? Yes, maybe, no? I mean, here's the thing, like, whatever, you're supposed to have two factors, right? When you factor a trinomial, you're supposed to have two factors. And all the, both of the factors, they're supposed to have the variable as the first term, right? So whatever variable you had in the trinomial expression, that should be the variable that follows each of the factors, right? So once you do that, whatever number you have in here, that should be your, sign. Whatever sign you had in here, that should be the sign for your first parenthesis. So if you know it's x minus, so there one of the numbers is going to be minus. So what should you do to the other number so that it adds to -1 and multiplies to -6? I know, okay, so if it's a negative, if the product is negative, I know one of the numbers has to be positive and the other has to be negative, because positive times negative gives me a negative. Negative times negative never gives me a positive. The only way you can have a negative product is when you have a positive and a negative number multiplied together. You were able to tell me that 3 and 2, these two are the two factors of 6. You were correct about that. So if you have 3 and then if you have 2 and you know that one of the numbers has to be negative, that should give you a lot, right? So then another thing that comes with this trinomial factoring is that you have the sign that you have in the middle, that should come here, and your bigger number should come first. So if you figure that out, that one of the numbers is -3, automatically you know the other number is +2. Because -3 plus 2 gives you -1, and -3 times +2 gives you -6. Right? So what are the three things that I told you? That's why I kind of like these things, because if you are trying to like move on, you have to make sure that you are clear about what you learned before. So it always like takes you back, right? So the first thing that I told you is that this middle sign, right? The middle sign, the mid sign, this should be in the first parenthesis, or in the first, I'm going to write parenthesis, in the first factor, right? The middle sign, whatever sign you have, right? That sign should be in the first parenthesis. And another thing that I said was like the bigger number goes first. So whatever number, if you can figure out, what the factors of 6 are, right? Between those two numbers, the first one should be the bigger one, right? So the middle sign should go first, right, in the first parenthesis. The bigger number should go in the first parenthesis. That should literally give you one of the factors. And you can literally figure out the other one, right? And another thing that I told you is the variable goes first. The variable should be the first thing that you should put. Variable goes first, that you should put in the parentheses. Right? This was like a review from the factoring lesson that we did before, right? Okay, so now all of that was just to figure out this part right here, right? All of those talking, all of those review was just for this part right here, which is why it's called a complex example. So once you figure the first, the top, right, you have to like factor the bottom as well, right? Because once you like, the first thing that you should be doing when like simplifying rational expression is factoring, which is why we learned about factoring before we are learning about rational expression. So what do we have? How do we factor this? Well, just by looking at it, I don't see, this is not a special form actually, right? So what do I have to do? GCF, greatest common factor, like, figure out what the GCF is and then factor that out. I can clearly see the first expression and the second expression, they both have 5 in them. So my GCF is just 5, right? So then I factored out 5, which is what I wrote in here, right? And then I divide each of the terms using my GCF. So 5x divided by 5 gives you x, cancel, the 5's cancel out, which is what is written in here. and then you have 5 divided by 5 gives you 1. What is written in here, right? So you are done with factoring this entire thing that you have at the beginning, right? And now time for this. Well, since you just have a constant at the top, you just leave it there because it cannot be factored any further. And for the bottom, it cannot be factored any further either. So you leave it like that. You just bring it down, right? All right. So now you look for common factors. They have been color-coded in here, right? So negative x minus 3, you have 1 at the top, and there's 1 at the bottom. So you can cancel them out, and you have a 5 at the top, 5 at the bottom, you cancel them out. So now you're just left with this one, and you are left with this. And that, if you just, bring them down, that should be your final answer. Do we have any questions, comments, concerns? It was a tough one. I'm going to give you that because of that whole factoring thing you had to do. Okay. Can we do like a practice problem, please? That is a video from Khan Academy. Please, please, please watch it if you are confused or if you need more clarification, okay? Try this problem right here. Because the only way that I'm gonna know if you understood it or not is through doing practice problems. So please try it and we are gonna go over it, okay? I'm gonna give you guys about 3 minutes to do the problem. Cross multiply. Oh, I see what you're, okay, Maggie, if you're trying to multiply this, it's a whole battlefield because you know why? Because you will have to like eventually end up, you'll have to like factor them. Because the only way you can cancel, you can simplify rational expression is by canceling out the common factors. That's the only way you can simplify it, right? The top and then the bottom, or like the top and the bottom from the other one, right? If they have like common factors, you have to cancel them. And that is the only way you can simplify it. So if you are thinking about like multiplying them, you can, but then remember, you have to, if you multiply it, you will end up with like 5x to the 5th power minus 20x to the 3rd power. And do you know how to factor that? I mean, okay, you probably, if you know how to factor that, because it should be factorable, if you know how to factor that, then go for it. But then that is just going to be a more complex factoring for you. Because even if you cross multiply from here, as you, if you like, if you decide to cross multiply as your second step, you can do it. But remember, you'll have to end up factoring the expression. Because the only way you will be able to understand if you have common factors or not is by factoring it. So if you do that, then you have to like, ask yourself, well, then how do I factor that? So I would recommend not doing it. Try to like figure out what your factors are for the top and then the bottom and try to go from there. Hi guys, you want me to go over right now?
Yes.
Yeah, sure. Alrighty, okay, so we have something here, we have something here. We have a fraction here. This is our first fraction, this is our second fraction, okay? All right, so what were we told? We were told that in order for me to like simplify it, I have to factor the top, I have to factor the bottom. Let's go from there. So factoring the top is already in its simplest form. I cannot simplify it anymore. So I'm just gonna bring it down like it was up there. For the bottom, right? Is the bottom factorable? Can I factor the bottom? 5x plus 10, can I factor that? Yes, we can. Thank you, Maggie. How do we factor that? Like, what method are we supposed to use? Yes, thank you, Maggie. We're supposed to use GCF. So I see we have a 5x and I see we have a 10. So the 5x and the 10, they have something in common. I told you guys previously that if the second term does not have a variable, like the 10 does not have a variable. In that case, your GCF is not going to have a variable. It is just going to be a plain number. What do 5 and 10 have in common? Well, the greatest common factor for 5 and 10 is just, sorry?
Is it 2?
Oh, you said 2, so is 5 divisible by 2?
Yeah, no.
I mean, 5 is divisible, but then you are gonna end up having like a remainder.
Decimal. Wait,
The
no.
greatest common factor is 5. Remember, it has to be the greatest common factor. Maggie said GCF. Yes, Maggie, that is correct. Thank you. So 5 is the greatest common factor, right, for 5x and 10. So now you divide each of the terms using 5. So 5x divided by 5, cancel out, it's just x, and 10 divided by 5 is just 2. So this is going to be my first term, x. This is going to be my second term, and it is going to have the same sign, plus. Right? So good to go for the first fraction. Now let's go for the second fraction. Well, for the second fraction is an interesting one. Why is it interesting? Look at the top. What is the top telling us? Like, how do I factor the top? Is the top even factorable? Can I factor the top?
No.
No, we can't, Zarif. Can we factor the top, Maggie? Yes, Maggie said yes, and I think Maggie is right. Here's why, Zarif. Because the top is actually a special form. What? Yes, the top is actually a special form because this is dots. And if you do not remember, dots is difference of two perfect squares. We learned about this, right? In our last week's lesson, that's like two perfect squares. You have a perfect square, x squared is a perfect square, and you have 4. Well, what are the two numbers that if you multiply, you should get 4? What are the two numbers there? If you multiply, you'll get 4.
2.
The same number, yep. 2 times 2 gives you 4, which is why I called 4 a special, which is why I called 4 a perfect square. So how do you factor perfect square? Well, to factor perfect square, I'm gonna have an x in here, an x in here, and I'm gonna have the square root of this number. Square root of 4 is 2. One of them is positive, the other one is negative. There you go. You have successfully factored this top. Let's go to the bottom. Well, x squared is just x times x, right? Ta-da! We have factored this entire given expression. We have factored the top and the bottom for both of them. Now, what should we do? We should look for common factors. Do we see any common factors? Do you see any common factors, Zarif? Common factors means you have to have the identical thing at the top and at the bottom.
5.
Yup.
5. What about on the other one? The x and the x?
You told me 5. You told me 5. Well, something that I should have done is x cubed is actually x times x times x. So I can write it down for you guys here. Right? So now look for the common terms. You told me about the 5s. Yes, we have 5s. X plus 2. Yes, Maggie. You told me the right thing. You have an x plus 2 up in here and an x plus 2 down in here. That is we found another pair of common terms. How about, do we have anything else? Is there anything else that you see? X, yes, thank you, Maggie. You have x in here, another x in here, another x in here, right? Is there anything else that is not red circled and you have that in both the top and the bottom? Do we see anything else? No, there shouldn't be actually anything else because I see everything from the bottom is actually canceled out, right? Well, then let's actually cancel out. This is actually the most satisfying part that I find. Canceling things out. Cancel, 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 cancel. This is actually the most satisfying part, you know? And now, what do we have left? Let me circle those. We have an x left in here. We have this entire binomial left in there and nothing else. So now whatever you have left, and you have actually one at the bottom, right? So whatever you have left, you cross multiply. X times x minus 2. You don't have to distribute. You can leave your answer in this form, in the factored form. You do not have to simplify that. Do you guys get it? Should I go over anything, any of the steps that we performed for this math? Tell me, guys, talk to me. Dave, if you want, I can send you a screenshot.
Okay.
All right, I'll send you a screenshot of the steps. Do you guys mind doing another practice problem? If not, then I'm gonna end class here, but if you guys want, we can do one more practice problem.
Sure.
Maggie, do you want to do one more practice problem, or are you already done? Sure, thank you. Okay. Alrighty, so this is our second practice problem. Let's get to it, guys. You guys want to do it together, or you guys want to try it by yourself first?
Together.
Okay, together is better. How about Maggie? You want to do it together, or you want to try it by yourself first? Yeah, do it together? Okay, let's do it together. But even though I told you guys that we're going to do it together, I'm going to ask you guys to tell me, to direct me what I should be doing, okay? Alrighty. So we see, okay, thank you, Maggie. Oh, we have a fraction in here. We have another fraction in here. Two fractions. So what should be the first thing we should be doing? Yes, I hear both of you guys yelling that we should be factoring first. Yes, we should be factoring first. Then let's factor. Let's factor the top. What is the top telling me? What is the top like literally showing me or directing me towards? How should I factor the top? Talk to me. Dots, yes, thank you, Maggie. We should do, I see like, okay guys, here's the thing. Whenever I tell you to like observe things, look for this. If the first term, or do you have, okay, so the only time you can do either dots or sum or difference, sum or difference of perfect cube is when you have two terms. When you have two, when it's a binomial, it's either gonna be like, if you're asked to factor it, it can be a dot and it can be a sum or difference of a trinomial. So if it has a square, if it has a second degree, then it's probably gonna be dots, right? And if it has a 3 or a cube, then it should probably be sum or difference of perfect cubes. So if you see a square, so a square or a 2, that should be dots. And if you see a cube, these are like exponents. I'm gonna put exp. So exponent of 2, right? If it's a second degree, then you're supposed to do dots. If it's a third degree, or if it has an exponent, if any of the terms have an exponent of 3, then it is gonna be either sum or difference of perfect cubes. Right? So look for that, okay? In here, I saw an exponent of 2, so that immediately told me, oh, it should be dots, okay? So how do we do dots? Talk to me, walk me through. So I know that, it is gonna have an x as the first term, because x is the variable that is given as the first term originally as well, right? So then what should I do? Yes, thank you, Maggie. Thank you so much. I appreciate your participation. So you were supposed to square root the 9. Square root of 9 gives you 3, right? So 3, one is positive, the other one is negative. Actually, square root of 9 actually gives you plus and minus 3. So square root of 9 is actually positive and negative 3, which is why you have positive and negative in here, right? Okay, so we are done factoring the top. Now let's talk about the bottom. Okay, so the bottom is what? What kind of factoring are we supposed to do for the bottom? All right, so back to our main problem. So this was neither GCF nor dots. That's actually trinomial factoring. Why did I say that? Because there are literally like 3 terms, right? There are like literally 3 terms that you see in here. And when there are like 3 terms, that's called a trinomial. Right? 1, 2, 3 terms. So it's a trinomial. And how do you do trinomial factoring, Maggie?
You find out what times what equals to -8 and the factors that add up to -2.
Thank you so much. So you have to figure out 2 numbers that will add to the middle number, which is -2, and that will multiply to the last number, which is -8. Yeah? So what are the 2 magic numbers? Okay, now, do you remember what I told you before? Like the variable comes first, yes, so I'm gonna put the variable, and what should be the sign in here?
The factors?
No, the sign. So I told you that whatever the sign is in here, the middle sign, right? That should be the same sign in here. So if it's plus, it's gonna be plus in here. If it's minus, it's gonna be minus in here. Yes, Maggie, did we understand that part?
Yeah.
Okay, so now you know that one of the numbers is gonna be negative, right? So we know that one of the numbers is gonna be negative, and we know that the numbers will have to add up to -2 and multiply to -8. So it is a negative number. One of the numbers is negative. And another question, always ask yourself, what times what gives me a negative number? Like, is positive times positive negative, or negative times negative negative? Or positive times negative? Like, what are the 2 numbers? What should be the 2 signs? If you multiply, you should get negative.
Negative and positive.
Yep, thank you. So if one of your numbers is negative, the other one should be what? Positive. Yep, you agree, Maggie?
Yeah.
So then what should be the sign in here? You know that one of the numbers is going to be negative and the other one is going to be positive. You know that, right? Okay, we know that. And we also know that the number in here should be the bigger number. That is actually a lot of like hints you have right there. So now tell me, what are the 2 numbers?
2 and -4.
2 and -4. Thank you. Remember, I told you that the bigger number goes here, so like that should be 4, and that should be 2, right? So 2 minus 4, or like -2 plus 4 gives you -2, so which is what I'm gonna write in here. Gives you -2, and -4 times 2 gives you -8, so they both check out. Bingo. Okay, we are done factoring the first fraction that we have. And now let's go to the second one. Actually, I mean, this problem actually did us a favor. You guys know what the favor is? You don't have to do anything to the second fraction. It's already like in its simplest form. So you can just bring it down like it was, like it is in the top. Bring it down. Bring it down. Now, what do we do next? Talk to me. What do we do next?
Cancel out
Cancel,
the same.
yeah.
Yeah.
Thank you, Maggie. Thank you. How do you cancel? You figure out the what? The common factors, right? So what common factors do you see?
X minus 3.
You see one in here, and you see another one in here. What other common factor do you see?
X minus 4.
And you ready to do the most satisfying thing? Cancel it out? Yes. Cancel, 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 cancel. What are we left with? We are left with only these 2 terms. I mean, not terms, but like these 2 binomials. And there's like 1 and 1 in here. So if you cross multiply, you're supposed to get x plus 3 x minus 4. And that is your final answer. You cannot simplify this anymore. When they're asking you to simplify rational expressions, you should leave it in its simplest form. Like, it cannot be factored anymore. How did it go? Any questions about this problem that we just did here? Any questions? Like, Tamana, how do we figure out like what kind of factoring to do? Like, and then how do I figure out the common terms? How do I leave it in the simplest form? Okay, guys, here's what this should be the key takeaways from this lesson. If you are asked to factor rational expressions, look at the top, look at the bottom of both the fractions. Look at the top. Is it x yourself? Is it factorable? If yes, then factor it. How do I factor it? Well, I know dots, right? I know grouping. I know GCF. I know sum and difference of trinomials. Not trinomials. Sum and difference of perfect cubes. Then ask yourself, what is the type of factoring that I should be doing in here? Well, I see a square. If it's a square and it's a binomial, right? So if it's a second degree binomial, right? If it's a second degree binomial, look for dots. If you have two perfect squares or not, right? If it's a second degree binomial and they're subtracted, please look for that. If that is a second degree binomial and if they're subtracted from each other, subtraction, then look for dots, right? Look for dots. If you have two perfect squares, well, then you're supposed to do dots, right? Bring down the variable, bring down the square root of the other number, right? And do one positive, do another negative. That's it, done factoring. Look at the bottom. Is that factorable? If yes, what type of factoring should you be doing? Look at this one. Well, there are 3 terms. If there are 3 terms, please do not look for dots. Please do not look for sum or difference of perfect cubes because it clearly is not. You cannot factor that using those 2 types of factoring. If there are 3 terms, you're supposed to do trinomial factoring. How do you do trinomial? Well, you're supposed to bring down the variable and then you're supposed to figure out 2 numbers that if you add, you should get the middle number. And if you subtract, if you add, you should get the middle number. And if you multiply, you should get the third number. Right? The middle number is usually a coefficient. So if you add, you should get the coefficient of the middle term. And if you multiply, then you should get the third number. That's how you do trinomials, trinomial factoring. Done. Look at the second fraction then. What is at the top? What is at the bottom? Are they factorable? If yes, factor them. Ask what type of factoring you're supposed to do. If not, do not factor it. Bring it down like it was. And now look for common terms. If you see common terms, cancel them out, cross multiply, and get your final answer. Right? It's all okay, so here's why factoring is like actually the most significant thing when you're trying to like simplify a rational expression, because if you do not know how to factor, you do not know how to simplify, because they will never give you this problems. They will never give you in simplified form. You have to like factor them in order for you to see the common factors, cancel them out, bingo, answer. Any questions, anything, any concerns, any comments? Anything, guys? Yes, no, maybe?
No.
No questions? I'm gonna